Hello, welcome back, students. We are working today on estimating area under a curve using two other geometric methods or numerical methods, and one of those is the midpoint rule. And for this rule, we will calculate the area of rectangles using the height of the rectangle at the midpoint of the delta x. So we'll be looking at doing a summation of those rectangles using your calculator, and we'll also do a little bit of looking at how that might be done by hand. So I have set up some formulas for you that when the time comes for us to have an assessment over these, I will give you this formula for the MIs. Those are your X values that you'll plug into the function. And then I would want you to know how to use those when you are using the summation formula to calculate the total area under the curve. So let's take a look at what it means to do a midpoint estimate of area under the curve. Now, I've actually already got all the calculations done for you on the right in my table, but I want to take just a minute and have us actually draw these rectangles on the given graph so that you can see what it is that we're actually accumulating. And then we'll talk about how to do this on the calculator. So the first thing to notice is that the function is f of x equals x squared plus 4x, and that our interval is from 0 to 4. So we'll be working with the graph that is shown. And the first thing that I'm going to do is calculate delta x. So again, A would be 0, and B is 4. And our number of rectangles that it said we would be using is 8. So our delta x would be 4 minus 0 over 8, or in other words, 1/2. So our delta x is 1/2. I set up the graph to be printed for us so that the delta x is laid out for us as 1/2. So with left and right endpoint rectangles, we could just start drawing either from the right and down or from the left and down. But with midpoint rectangles, we need to find the point on the curve that is at the midpoint of the interval. So for example, our first interval is from 0 to 0.5, since our delta x is 1/2. So the midpoint from 0 to 1/2 is 1/4. So at 1/4, my y value would be determined by whatever the y value is on the curve when x is 1/4. Well, that is the height at which I'm going to draw the rectangle. So the rectangle going through the midpoint of the interval will still have a width of 1/2, but its height is determined by that midpoint height. So not by a left endpoint or a right endpoint, but rather by the midpoint. And I'm going to do that for each interval. So from 1/2 to 1, my midpoint is 3/4. So I will put an order or put a point on my curve at 3/4 and then draw a rectangle through that midpoint. And I'm going to go ahead and do that. I'd like for you to do that as well as you are hopefully completing these notes. So each time I'm using the midpoint of the interval as the height at which I'm going to draw my rectangle. And fortunately, I had things set up for us so that the midpoint of the interval is on a grid mark for us. So you can see the rectangles being drawn. So remember, I'm putting a point on the curve at the midpoint of the interval. And finally, my last one, whoops. So after I draw this last rectangle all the way down to the x-axis, I'll go ahead and label my rectangles. So the first one is rectangle 1, rectangle 2, rectangle 3, rectangle 4, rectangle 5, rectangle 6, rectangle 7, and rectangle 8. So you can see the 8 rectangles. I'm hoping that this part of the notes resembles what you did on your first problem of your homework in the last assignment, where you did a right endpoint series of rectangles and then a left endpoint series of rectangles and did a comparison of the summation of the areas. So this would be another comparison that we're going to make. You'll notice over in the table that I'm just going to briefly explain it. So for rectangle 1, the midpoint x was at 1/4. Again, that would be halfway between 0 and a half. So this is the x value that I substituted into f of x, which was x squared. So 1/4 squared plus, and then 4x. So 4 times 1/4. And then I calculated the area of that first rectangle using my height, f of x, times my delta x, which was 1/2 every time. So you can see that I did this for each rectangle all the way to rectangle number 8, where my midpoint was 15/4, and substituted that into the f of x, and then calculated the area. So I can add up all of these areas and find out what my total area under the curve is. And if you wanted to do your rectangle problems in this way, you actually could do that. Now, I find it to be very cumbersome, but you can do your work this way. This would be numerical integration, and you're just calculating the area of all 8 of those rectangles and then adding them together. But I thought that since that's very cumbersome, we might want to use our, especially the Desmos graphing calculator, to do the summation. So I came up with a formula that will work as a substitute for x that will produce the correct height values. And that formula is, and I'll work with it on this side of my screen. You should have plenty of room on your paper. My formula for MI, which I have at the top of this page is A plus delta X over 2 plus I minus 1 times delta X. So let's substitute in. Mi would be A, which is 0 in this problem, plus, now our delta X is 1/2, and that is over 2, so 1/2 divided by 2, plus I minus 1 times 1/2. All right, so our Mi, we won't need the 0 anymore. 1/2 divided by 2 is the same as 1/2 times 1/2. That would be 1/4 plus, and then 1/2 times your I minus 1, we can distribute to make 1/2 I minus 1/2. And then simplifying our Mi, we could combine like terms. 1/4 and negative 1/2 would make negative 1/4 plus 1/2 I. And so that will be the expression that I'll use as my X value to substitute into the function as I do my summation. And so your area is going to be a summation, and I'm going to go ahead and write out what that would be. So F of Mi would equal, now we're going to be using our formula, so that would be F of negative 1/4 plus 1/2 I, and that means that we will be substituting into X squared. All right, now that would be negative 1/4 plus 1/2 I squared, and then plus 4x. Well, again, your x is negative 1/4 plus 1/2 I. So as we calculate the area will be a summation from I equals 1 to 8, 8 being your number of rectangles. So I equals 1 to 8. And since I already did my F of Mi, I can go ahead and write that in. So that will be negative 1/4 plus 1/2 I squared plus 4 times negative 1/4 plus 1/2 I. And then I do need to remember that this is my height of the rectangle, and I need to multiply that by the width of each rectangle, which was my delta X, or 1/2. So now we can substitute that into Desmos. Now, I will make a comment that if you are not using Desmos, you will probably need to simplify the expression much, much more than what it is now. Without taking the time to substitute into Desmos for you, since you have already seen that happen, I'm going to go ahead and just tell you that the answer you should get is 53.25 square units. And if you would double check, you would get the exact same thing by doing this calculation using the numerical table. So 53.25 square units. So once again, this is calculating the area under the curve using a midpoint estimation or a midpoint approximation. You are welcome to use the table if you want. This is how you would want to set it up. Or I think more likely you will use the Desmos and use the summation process. So there's your first example, and that is all we're going to do with the midpoint rule. If you will turn your papers over, we will continue on with the trapezoid rule.